Welcome to Highline Excel 2013 class video number 50. Hey, if you want to download this workbook and follow along for week 10, click on the link below the video. In this video, we want to have an introduction to financial functions, and we're going to look at PMT rate, NPER, and future value. Now, we have 9 different examples, and some of them are directly related, some of them are not. They're kind of a selection of financial examples I might do in my finance class. So for this class, it's not a finance class. Or even in my business math class, we talk more about the theories of finance and whatnot. What you want to take away from this class is that there are financial functions in Excel, and also that we want to be able to think about cash flow. Now let's go over to this note sheet. Now we're going to talk about the PMT function, and that calculates the amount of your payment on a loan and other periodic payments. We'll also talk about the future value function. That tells you how much, if you put some money in a bank or you have a savings plan, how much you'll have later in the future. We'll also talk about the rate function. That calculates your interest rate for a period. And we'll talk about the NPER function. That calculates the total number of periods. For example, we'll use it to calculate how many periods or how many months it will take us to pay off our credit card. Control Home. The one finance concept that we'd like to kind of understand after watching this video is that cash flow matters in finance. Now, when you have a monthly payment on a loan, to you, that's cash going out of your wallet, meaning I'm writing the check and sending it to the bank. That's negative. If the cash is going out, it's negative. But to the bank, when you send in your check to them, the cash is coming in. It's a positive. So we'll always ask the question when we're talking about cash flow, which way is the cash going? Is it coming in? Is it going out of my wallet or into my wallet? Out of the wallet, or purse for that matter, is negative. Into the purse or wallet is positive. All right, let's go over to our first sheet, PMT, and we want to see 5 amazing examples for the PMT function. Now here's the situation. We have a car. There's the price. That's how much we've borrowed. And we need to figure out what our monthly payment is. Now, when you go to get a loan, they almost always quote you the annual rate. And they say how many years the loan is for. But if our goal is to calculate monthly payment, we can't use the annual rate or the number of years. We have to figure out what the monthly rate is and the total months for the loan. The reason why is if we're calculating monthly payment, everything has to be in the same units, month. All right, now I already did this first formula here. The amount we need to borrow, well, we take the price of the car minus the down payment. So that's the amount we borrow, and now we need to figure out what the payment is at the end of each month. That's going to be our monthly payment. But first we have to calculate our monthly interest rate. Well, we simply make a formula equals the total annual rate, and we need to chop it into 12 pieces. So what do? We divide by the number of periods in the year. Now, for most consumer loans, or many consumer loans, we're doing monthly. Later in this video, we'll have an example where the corporation is borrowing some money, and it's quarterly. We pay quarterly payments. But here, annual divided by 12, that's our monthly rate. Now, number of years, we need total number of periods. So we say, hey, years times number of periods in our year, which happens to be 12. All right, so that's what we use, our period rate, which is our monthly rate, and our total number of periods. Now, let's go ahead and use our PMT function. Now, there's a bunch of arguments here, and there's notes over there. But the rate is always going to be the period rate, the interest rate. So we're going to say monthly, comma. NPER means number of periods. And in particular, it means total number of periods. So that's 60. Comma, the present value. Present value just means on the day you went out and borrowed the loan, how much was the loan worth? What is the present value of that loan? Well, it's $24,799. But here's our first cash flow. This was a rate and number of periods, so we didn't need to worry about whether it's negative or positive. But this is a cash flow. And this is kind of tricky, because you never really see it. It just, you borrow it, the bank gives it to the person you're buying the car from. When you go out and borrow the money from the bank, that's a positive to you. You say, hey, bank, can I have some money? And they give it to you. So that is a positive. Even though for that fraction of a second you get it and then you give it to the car dealer, it's still positive from your point of view. All right, now the remaining arguments, future value, that's if you had a balloon payment at the end. And type means the type of loan it is. Most consumer loans, you pay your amount at the end of the period. Also for a lot of finance things like savings plans, you always save at the end of the period. So when you have periodic payments, that means payments that are the same amount each period and the time period between each payment is the same, most of the time it's at the end of the period. An example of when you have a beginning of the period payment is like on a lease. Now here's the deal. We can put the 0 in, but the default for payment is end of the period because many loans and payments are at the end of the period. So guess what? I don't need to put that in. Comma, I'm backspace and get rid of that. Not only that, but since there's no future value, I can backspace and get rid of that. So for most payments on consumer loans, that's all you have to put in. We'll see examples of those last two arguments a little bit later. All right. Minus. Why is it minus? Because these functions understand cash flow. That means every month, $485.22 is coming out of your wallet and into the bank's wallet. Now, just out of curiosity, if we didn't have that PMT function, and in my finance class, we learned the annuity formula for this particular finance calculation, and that's what it would be like. So instead of having to calculate that and type that out each time, much nicer to have the P. Oh, that is amazing. Look at how easy that is. Now, what if the payment happened to be at the beginning of the period? Well, it'd be the same exact thing. Period rate, monthly rate. By the way, the bank would love for you to use this gigantic annual rate because then you'd be paying them a lot more. All right, so rate, total number of periods, present value, it's positive for that little fraction of a second, comma to skip over future value, and then here, if it's at the beginning, we have to put a 1. Close parentheses. Now, if you pay right when you get the loan, your first payment, that means you're paying something early, so the total payments will end up being less. Look at that. We're going to pay about $3 less each month for all 60 periods just because we paid 30 days early or 1 month early. That's a fact that comes from compound interest, the power of compound interest. In a finance class, we talk about that here. But all you need to know here is your loan payment is going to be a little bit less each month just because you paid 1 month early. Now, let's go look from the lender's point of view. The loan amount is still going to be the same, price minus down payment. The monthly interest rate is still going to be, hey, that annual rate divided by the number of periods for the year, and the total number of periods will be years times periods per year, which would be 60. So we come over here, and this is going to be from the point of view of the lender. So the rate, period rate. Number of periods, same for both the borrower and the lender. But the present value is going to be negative because the bank, when they loan this to you, it comes out of their wallet. All right? So now that means if this is negative here, if the cash flow here is negative, then that means the PMT is going to be positive. And sure enough, for the bank, that's coming in each month. Now, here's the whole formula here. I accidentally had a minus sign there, so I'm going to put that as a positive. All right, so let's go look at our third example. Oh, sometimes you have a balloon payment at the end. So we're going to buy a car for $50K. The down payment is $5,000. Looks like I forgot to put the green there for formula. So we subtract those two, and we have to borrow $45,000. We're going to have a balloon payment at the end. That means we're going to be paying off a little bit every month. But at the end of the loan, there's exactly $5,000 we still have to pay. All right, our period rate, which is monthly, is, hey, annual rate divided by number of periods per year. Our loan is for 3 years. So here we're going to say equals 3 years times 12 periods per year. And now we can do our monthly payment equals PMT. The rate, 0.44%, comma, the number of periods, 36. The present value, this is from our point of view, the borrower, so it's positive, comma, the future value. Now, at the very end of the loan, from your point of view, do you have to pay $5,000 to the bank? Yes, you do. So that's why it's negative. When we borrowed the money, this $45,000 was coming into our wallet, even though it immediately went out. At the end, we're paying $5,000 to the bank, so that's why we put it as a minus. The last argument, the default is end of the period, and that's what type of loan this is. Control Enter. And there's our minus $1,225.21. It's minus because each month, that's how much we're paying. Wow, that's a lot of money just for that $50,000 car. Now, let's go look at our next example. All right, so this example, we're a corporation. We go out and borrow $1 million. The annual interest rate is 8.5%. We're going to do it for 6 years. And there's 4 periods per year, so we're paying quarterly. Now, here's the thing. We're going to put off paying any payments for 1 year. Now, the bank who gives us the loan is not going to do it for free. That means the $1 million that we borrow and start using, it's sitting in that bank account as a loan, and every 3 months, every quarter, the interest is accrued. That means by the time we start making payments 1 year later, the amount that we actually owe is going to be a lot more than $1 million. So that's where the future value function comes in. We're going to say, hey, $1 million, please show us what the amount we owe will be in 1 year. So here we're going to use the future value function. Oh, but we have to calculate the rate in NPER. So annual rate divided by 4 periods per year. So our quarterly rate will be 2.13%. That's our period interest rate. Our total periods equal 6 times 4. That's the total number of periods. Now, we have to be careful there. We're actually not going to use that number because we have 2 calculations here. Here we have to figure out how much do we owe after 1 year, which means 4 periods of interest payments accrued on top of this $1 million. When we get to the period payment or the quarterly payment, we're only going to have 5 years left. All right, so we just have to be careful about that when we make our calculations. All right, we're going to see how to use the future value function. The rate, well, the period rate is 2.3%, comma, total number of periods. Now, I'm going to be careful here. I know it's 4 because it's only 1 year, but I'm not going to click there. I'm actually going to say total number of periods is 1 year times 4. That way, for this template, if I come back later and in that cell I put a 2, which means we put the payments off for 2 years, this formula will calculate correctly with the total number of periods. So the total number of periods is just 1 times 4, which is 4. Comma. We don't have any payments that we're making here, but we do know what the present value is. So we get the $1 million, and it is positive. Now, the type is end. And what do you think the cash flow will be here for future value? It's going to be negative because this is a loan account. So that means if we borrowed $1 million and we didn't pay any of the interest after 1 year, that's how much we'd have to pay back to the bank. On this, for this particular calculation, the cash flow is negative because if we paid it back, we'd be paying it out of our wallet to the bank. Now, you ready? We're going to calculate the period payment equals PMT. The rate, still this 2.13, that's the period rate for the quarter, comma. Number of periods. We have to be careful here. The loan was for 6 years, but now we're making this calculation 1 year out. So it's actually 5. And we need to take that 5 times the number 4, which represents quarter. So in parentheses, remember, we're always building our formulas robustly so they update. So instead of putting a 5 there or something, I'm going to say 6 minus 1. That way, if we change that number 1, year's payment is put off to 2, this NPER right here will calculate correctly. If that was 2, then the number of years for this NPER payment would be 4, right? 6 minus 2 would be 4. But for us right now, 6 minus 1 is 5. Now, that's years, and the units always have to be the same. So for NPER, we have to say times 4. That will give us our 20, I believe it is. So watch this. We could do our little trick. As we click around in our arguments, I could highlight just what's in the argument. I can hit F9. That's the evaluation key, and see that, yes, it gives me total number of periods, 20 for the rest of this loan. Control Z. Comma. Now, the present value, this is just like making a calculation for a loan, right? But think about this. Even though for this calculation right there, when we calculated it in the green cell, it was minus, that's because if we paid it back, it would have come out of our pocket. But now we made that calculation, and this is going into the future, so we have to make this present value positive. Because remember, when you go to the bank and say, hey, can I have some money? They give it to you. So that's where we're going to put a minus sign to convert it back to a positive. F9, we can see, sure enough, it is a positive. Control Z. Cash flow sometimes get tricky in finance. You always have to break it down and think about exactly what's going on. All right, PV, we have that. There is no balloon payment at the end, and our type is end of the period, so I'm going to leave both of those arguments off. Close parentheses and enter. Wow, $67,328.25. Obviously, not for a consumer loan, but borrowing $1 million for a corporation or some business might not be a big deal at all. That's going to be the quarterly payment. All right, we have one last example on this sheet. Here we want to calculate adjusted APR when there are points and fees. Now, if you go out and borrow $200,000 for a house, the contract says, hey, there's points and fees. And a lot of us don't think about that, but points mean they're going to actually take some of this. So even though you owe the $200,000, the person initiating all this is going to take 1% of that. Not only that, but there's a $750 fee on top. I wish they wouldn't disguise it this way and they just say, boom, here's our fee. But that's the way it goes. It's no problem. That's why we're learning how to do this finance, so we can calculate what it should be. Now, since we borrowed $200,000, we're actually going to have to make our periodic payment here based on that $200,000. But when we go to figure out what the adjusted APR is, that's where we take into consideration these. All right, ready? The period rate equals 5% annual rate. Notice I have it as a decimal here. It does not matter if you have it as a percent or a decimal. So that divided by number of periods. Enter total periods. This is a 30-year home loan, so 30 times 12 will give us 360. The PMT equals PMT. The rate, that's our period rate, comma, total number of periods. The present value, that's the full $200,000, and it's positive because we go to the bank and say, hey, give us some money, and it plops into our wallet, right? But we immediately give it to whoever we bought the house from. No balloon payment at the end, and this is N, so we leave those last two arguments off. Enter. So $1,073.64. Now, actual cash received. This is where we get to figure out actually how much money we got, because that immediately went to someone else for servicing our loan. So 200,000 times, well, it's 99%. 1 minus the 0.01. And we could highlight this and F9 it and see, yeah, sure enough, 0.99. So the actual cash received is 99% of that 200,000. Control Z. Again, we're linking it to the cell. Excel's golden rule is if formula inputs can change, you put them in the cell and refer to them in the formula with the cell reference. All right, that'll give us the full amount that we are receiving before the extra fee. So 198,000, Control Z, but there's one last little bit. They're going to subtract 750. Enter. So they're 197,250. That's the actual cash we received. All right, the period rate. Oh, we have to count. I thought we knew the period rate. But no, we need to figure out the actual period rate because we thought we got 200,000, but the cash flow is actually 197,250. That's how much we got. So check this out. Now we're going to use the rate function. Rate always calculates the period rate. That means the monthly rate for us. So NPER, it's still the same. 360. Notice how future value, PMT, rate, they all have the same basic arguments. It's just we're solving for a different piece. We're solving for the period rate here. So NPER, that still means total number of periods. PMT, that's a cash flow from our point of view. So we put it in as negative. The present value, that's why we had to calculate the actual cash received, because from our point of view, this is how much we used to give to the person that we bought the house from. These extra fees went to the person who serviced the loan. So there it is. And it is positive. That comes into our pocket. Cash flow is important here. The PMT is negative. The actual cash received is positive. We do not have any future value, balloon payment at the end. We don't have this is a consumer loan, so it's at the end. And we don't need to put a guess in here. So we're simply going to close this off. And it's 0. I love that. We're dancing. No, that's number formatting. Don't get tricked by number formatting. Now, we know the eraser is the general number format. But don't forget as you go forward, since this is one of the last videos for this class, Control-Shift plus either tilde or grave accent, either one of those. That's the keyboard for general number format. Control-Shift, grave accent, or tilde. There is our period rate. And notice it's a little bit bigger than our period rate we used up here. Now we can calculate our adjusted APR. So equals, well, period rate. How many periods in our year? 12. So there we go. That will give us our adjusted APR. And it is a little bit bigger than our 5% up here. 0.05, 0.05, and a bunch of extra change. So the adjusted APR is bigger than our annual interest rate. Not only that, but you want to remember that this $200,000 that we borrowed, part of that went to pay off the points and the fees. Whatever was left over was what we were allowed to use for our house. Now, here's our PMT. And it's based on the whole amount, even though we had to break that apart, pay some fees, and pay the house. That $1,073.64. We're going to send that amount in every month. Now, our next example, we want to go over to the sheet amortization, because that $1,073, when we send it into the bank, part of it gets used up as interest, and part of it is a reduction of our loan. So let's go over and build an amortization table. I'm going to click on the sheet amortization. Here's our details, and there's our PMT. Now, every month you send it in, we'll have a column for payment. We'll have a column for period interest. That means how much the bank takes as interest each period, and then how much the bank reduces your loan by. Now, before we can calculate this, we need 360 rows, because the amortization table will break this apart into its two pieces, interest and loan reduction, 360 times. Now, watch this. Here's a great trick for putting numbers into this first column. I need 0 all the way to 360. So I type 0, Control-Enter. And watch this. When you point your cursor to that fill handle, right-click and drag down and then back up. A special menu pops up, and you point to Series. Immediately, it asks you, where do you want to put this series of numbers? In rows, which would put them this way, or in columns, which would put them this way. That's what we want. We want 0, 1, 2, 3, 4, 5, 6 to 360 in this column. The step value, 1, because I want to go 0, 1, 2, 3. And the stop value, 360. I absolutely love this trick. OK. And just like that, Control down arrow, it put in all of those numbers. Control home. Now, we have times 0 because when we go to the bank, we borrow exactly 200,000. So the balance at times 0 is equal 200,000. Now, for each period, we in this column want the payment amount. So I'm going to do a cool trick here. I'm going to type minus the payment. Now, for the amortization table, I don't want to show it as a negative. I want to show it as a positive. So I need to do double negative. But notice I didn't put an equal sign there. Control Enter, F2. Anytime you put a minus sign or a plus sign, Excel will convert it to a formula by putting an equal sign before the minus, plus, or at symbol. F4 to lock this all the way down. Control Enter, double click and send it down. Control down arrow, 1,073.64, exactly 360 times. Every month I'm sending in the same amount. Now with my cell selected, I'm going to highlight the whole table, Control asterisk on the number pad, and then I'm going to use my all borders. Now, let me add some color here. Double click and send it down. I'm going to add some color to this whole row here. All right, now that's the amount that we send into the bank. Part of it's going to go as interest, and part of it's going to go as loan reduction. Well, the most important calculation in this whole table is period interest. And here's how it's calculated. Well, when you went to the bank and borrowed $200,000, it was sitting in there for a whole month until they calculated interest. So at that point, they take the period interest rate and multiply it by the 200,000. So you ready? Hey, how much was sitting in the account for the whole month? 200,000. That's what you owe them. So we have to calculate that amount times the period rate. Now I'm going to lock this, F4. All right, Control Enter. So for this first period, you sent in $1,073.64, and they took $833. That seems like a lot of interest. The reason why is because you owed them $200,000. A lot of money. As we go down the amortization table, the actual amount of the balance will get smaller and smaller. And that's why as you send in more and more payments, your interest will go down and your loan reduction will go up. So our loan reduction equals the PMT minus the period interest. Control Enter. Wow. I sent in $1,073, and they only let me take off $240 from my balance. Yep, that's the way it works. Early years, high interest, low loan reduction. Later years, high loan reduction, low interest. All right, so our balance equals one cell above minus one cell to my left. Control Enter. Let's see if we got all of our cell references right. Those are relative all the way down. That one's relative because as we copy the interest down, when it gets down to here, it'll be looking at the balance from the period above, which will be getting smaller each time, and thus the interest will get smaller. Actually, let's copy this down a few rows. Notice 1, 2, 3 different formulas. I'm going to just drag it down a few rows. Double click this. The reason the interest is going down is because our balance, the amount that was sitting in the account for the whole month, is getting smaller each period. This is getting bigger each period because the interest is getting smaller. Now watch this. I'm going to highlight all three formulas and double click and send it down. I can send all three formulas down. Control down arrow on this last number better be 0. Exactly perfect. So on the last payment, we send in $1,073. About $4 is interest. About $1,070 is loan reduction. Control home. That's an amortization table. Every time you have a PMT for a loan, some of it's interest, some of it's loan reduction. Now we can calculate the total interest. And that would just be Alt equals for the sum function. Click in the first cell, Control Shift down arrow. Shift Enter to put the formula in the cell and push the cursor back up. I'm going to copy this formatting with my paintbrush. This one I'm going to use, I actually could have done the paintbrush there too. That's a lot of interest. And I want to show you another option too. There's a function called CUMIPMT. PMTI, which would be the cumulative payment interest. So let's see if we can copy this. Control-C, Control-V, and I'm going to try a different function, equals CUMI. CUMI, which is CUM for cumulative, I for interest, and PMT for payment. So the rate, NPER, that's the total number of periods. The present value, it is a positive. The start period is going to be 1, and the finished end period is going to be 360. And the type is going to be in this requirement. Notice there's not a square bracket around type like there was with PMT, so we have to put it in. It's going to be end, close parentheses, and Control-Enter, and we get the same exact number. That's another financial function. That's pretty cool. Now we want to go over to our next sheet, how long, and look at the painful truth about credit cards. How long to pay off your credit card balance. So it says $7,500. That's your balance. And up in the corner it says your minimum payment is $125. A lot of people pay that and don't think about it. That would be awful. Not only is it tons of interest, but it's going to take a long time. So let's figure out how long. Now we have the present value, that's a loan. A credit card balance is like a loan to you. That's a positive. We have our annual rate, number of periods per year. There's our PMT. With those inputs, we could use the NPER function to figure out total number of periods. The rate, we're going to have to calculate it right inside of our argument. So the rate function calculates 18% divided by 12. The PMT, that's minus. That's a positive. It's a loan coming in. That's going out of our wallet, so it's minus. The present value, sure enough, that's $7,500. We don't have a balloon payment at the end, and we can leave the argument off because it's got those square brackets, and we know the default, it's end. Oh, that hurts. 154 months. If we take that and divide it by 12, that'll tell us it's going to take a lot of years. And if you build an amortization table for this, that would be a lot of interest. How long? Too long. Don't pay your minimum balance. Now we have one last sheet for this kind of introduction to financial function video. FV annuity end. Now an annuity just means regular payments in regular intervals, usually for like savings plans or withdrawal plans. So here's our question. We have a savings plan. If we put $50 in the bank at the end of each month for 50 years, how much will you have when you retire? Well, if it's 50 years, you're starting when you're still a teenager, which is when you should start saving. $50, it doesn't seem like a lot. The variable that affects compound interest the most is time, years. Now we're going to start off with 0.3 as our assumed annual interest rate. That's a lot. 13%. If you look back at financial history over the long haul, the averages with stocks, you can get about 13%. We'll start here and we can move it down. I'm shooting this in 2013. Certainly 2013, we had rates higher than even 13% for this year. But between 2008 and 2012, there were some pretty bad years there. So that's why it's a formula input. We start with 0.3, make our calculations, figure out what we'll have when we retire if we put in $50 each month for 50 years, and then we can change it. All right, equals period rate, 13 divided by number of periods per year. Total periods equals 12 times 50. And then future value equals FV. After using these financial functions, you kind of get the hang of these different arguments. The rate is always period rate, comma, the NPER, total number of periods. The PMT, oh, this is going to be negative, right? Because we're putting it in the bank. So I'm going to put a minus sign right there and click on 50. That makes sense because when on the day we retire, the future value better be coming to us, which is positive. No present value, that would mean some amount you started off with in the bank, a lump sum. And the type is going to be end. Wow. That is amazing. Almost $3 million. That's the power of compound interest. And check this out. Even if we assume 0.1, you still have about $860,000. And that's a lot of money when you retire, because on the day you retire, you don't spend it all. It sits there and keeps earning interest while you withdraw regular amounts. Yeah, so just at a quick look here, we're lucky we have the future value function, so we don't have to do this annuity formula, which is beautiful, but that's a lot easier, especially if you're doing finance and doing this kind of stuff day in and day out. Now let's just assume something. Let's say you get this on the day you retire, and we want to figure out how much we can withdraw each month. We're also going to need to know what the present value is, because we're going to have withdrawals each period. Well, that's the amount we got on the day we retire. But if we immediately put it back in the bank and just let it sit there, then that would become the present value. And guess what? We're going to call this a negative. And so I'm going to go minus this. I'm going to change this formatting, come up here, currency. And now we want to figure out what the PMT, how much we get to withdraw each period. So in this cell, do a little formatting here. So in this cell, we're going to do equals PMT, the rate, 5% divided by 12, comma, the NPER, 35 years, times 12. The present value, it's that amount right there. And I don't want to have anything left over. I could put an amount there if on the day I died I wanted some left over to give to my kids. And the type will say, I'm going to do begin. So we're going to go comma, comma, and then begin, because I want some right now. And so that's a lot of money, $4,300 each month, based on the fact that we had $866,000 on the day we retired. Now we could do one step further. Total withdraw. And I'll come up here and change the column width. Copy. I'm going to paste this here just to get the format in, then change the formula, escape. Equals this times what? Times 35 years times the 12 months. And boom, from $866,000 on the day we retired, since we get to withdraw, assuming a 5% annual rate, that's pretty conservative, about $4,000 each month, that's the total amount we will have withdrawn over the period. So even when you retire and have $866,000 on the day you retire, just from putting $50 a month away, you're still going to get $4,000 each period, and that's a total of $1.8 million. You know, we could actually do one final calculation. I'm going to scroll over here and say total put in. And that just means how much did I actually put in. Guess what? This is going to be really small, $50 times the 50 periods times the 12 months. You got to be kidding, $30,000. And total withdrawals after all those years, $1.8 million. That's the power of compound interest. All right, we have one more calculation here. Boy, is it fun playing around with these financial functions. What if I wanted $1 million on the day I retire? And I'm going to plan to save for 35 years. We're going to assume a rate of 13%. No problem. Remember, how much do we have to put in each period to get this $1 million? If you're putting a certain amount in, or there's a cash flow that's always the same size and the same time periods between each cash flow, we can use the PMT. Now, the PMT function is the function we've seen the most throughout this video. We saw it for loans. Now we're seeing it for investments, right? Or even up here, how much do we get to withdraw once we have $866,000 here? The question is, how much do I have to put in the bank to get $1 million? So my target is in the future $1 million. All right, period rate equals 13% divided by 12. Enter. Total number of periods equals 12 times 35 years. And now we'll simply do equals PMT. Always being careful about our cash flows. There's our period rate. There's our total number of periods. The present value, well, if I had some in the bank, I would put it there, but I don't have any right now. And the future value, I want it to be positive, so there it is. I can skip over the type. I'm going to assume this is at the end. Not only that, but this is going to come out negative as a cash flow because that's how much I have to put in each period. The power of compound interest. If I only got 0.10, so 10% annual return, which over 35 years, at least history says that that's possible. History is, on average, a good guide for the future, but the future is unknown, so we don't know. All right, so there we go, $263 per month for 35 years, and I can have $1 million if I get that 10%. All right, that's a lot of fun stuff with financial functions. The only big important function we didn't look at is present value, and that has to do with the present value concepts, present value of future cash flows, and that we'll save it for a finance class. All right, hey, there is a link below in the Show More area for the finance series I have at YouTube, which is 111 videos. It's a basic kind of finance, corporate finance class that goes over some accounting and lots of cool finance stuff. All right, we'll see you next video.